Hello, this is Professor Stephen Neshaba, and I'm here to help you out with setting up some calculations on Spartan as part of our the first exercise, the computational exercise that we have on Spartan. So, in order to make best of use of this, you should launch Spartan and come back and when you're ready and have the screen in front of you, let's just get started. Okay, so the first thing to do is I want to create a molecule, so I'm going to go to that upper left-hand corner. And the first molecule on our list is water. And if you see up here in the upper right, you can see that we kind of have our choices of organic molecules, inorganic molecules. Doesn't really matter. Organic molecule, I can see some water out there, and since I know water has two hydrogens on it, I'm going to click on that, and then after I do that, I click on this space, and there's water. Now it's assumed that if in Spartan, if you see these yellow guys here, that means that there's some hydrogens there. If you want to just check that, and a single click on this minimize button, you can see that it tries to adjust the bond lengths a little bit and so forth, but it also shows you those hydrogens. Now, because you're going to be using these in class, let's save that. I'm going up to that icon there to save, and I've set aside a folder to put that in. Now, Spartan has been smart enough. Actually, it already knew that this was water, so it defaulted to that name, and so that's good. Now let's do another one. Let's see, the next molecule on our list is hexane. And if you don't remember what hexane looks like, well, you should consult your lab notebook because you made line drawings of hexane in your laboratory notebook prior to this. But I've looked it up in Wikipedia, and there's the line drawing for it, and I can see it's got 6 carbons with hydrogens on it all over. So that's what I want to make. I'll just say new again. And I'm still in the organic model kit area, and I'm going to click on this icon here for carbons that has 4 bonds to it, which is what I want. And now I'm going to click, there's one. And now all I really need to do is just keep on clicking to create more carbons. That's 2, 3, 4, 5, and 6. And if you want, you can do a little bit of adjustment, the energy minimization on this, and just to show the hydrogens show up. That looks pretty good to me. There is a nice way to center things. I'll show you that. You go up to Edit, this pop-down menu and Edit, and dial up Center. Yeah, so that puts it over there. Don't forget that you can left-click and rotate this molecule around, which I've just done there. All right, that looks good. I'll save this one. And it looks like Spartan has figured out that this is a hexane. It's a particular kind of hexane called N-hexane. I'm fine with that name. Now let's see, we'll do one more. Let's see, what is the other one that we need to do? Or rather, you have several, but the third one I'm going to show you in this video is ethyl acetate, which is what this is what Wikipedia says ethyl acetate looks like. So we'll just kind of build this right here. And all right, I'm going to go back to Spartan. So the first part is this a CH3 group. So I'll go ahead and start that new. And well, I've already got that one going, so I'll click that there. There's our CH3. Now, because of the way this was laid out, it looks like I need to make my next bond sort of up and to the right. You don't have to do that for this, but I'm going to rotate it just so it kind of looks like that for you. I'm interested in that bond there. Now the next carbon is a carbon that has, it's what we call an sp2 carbon because it's got a double bond. So I'm going to go back to Spartan and pick up the sp2 carbon right there. Click on it. And let's see what that's looking like. Oh, there is the double bond. And I'm going to try to make that point up. Good. I know that I need an oxygen double bonded to the top there, so I click on there. Good, and now what else do we have? Oh, I need another oxygen down there, and that's going to be not a double bonded oxygen, but an oxygen with 2 bonds. Off we go. Now, I need to finish up my molecule, but according to my picture, I sort of wanted that to go up like that. Again, this is not necessary for you to do, but I'll just show it to you. You see how that bond is I can highlight that bond, and if I hold down the Option key on my Mac, also the Alt key, I can rotate that just along that bond, so that's nice. Now it's pointed that way. Let's see, I need to have an sp3 carbon attached to it there. There we go. And another one right there. I think that that is my ethyl acetate. I'll do a little energy minimization, kind of fix things up a little bit. And I think that's good. I will save. And let's see what... Oh, look at that. Spartan knew that it was ethyl acetate. So I'll just save that. Okay, so those are the first three molecules that are in this computational lab on intermolecular forces of organic molecules. And the first part of your, or rather this is the second part of your what to do in preparation for this activity. You've already drawn the carbon skeleton structures. These are water, hexane, and ethyl acetate that we've done. You should go on to make methyl benzoate, biphenyl, and benzoic acid. So where are you going to find those those structures? Well, you could do what I did, go to Wikipedia and enter into the into your search window. What was that? It was methyl benzoate, methyl benzoate, and there it comes up in Wikipedia, and there's the structure of methyl benzoate, and you can proceed that way.